Welcome back, 7th graders, and welcome to Chapter 8 in your textbook, starting on page 416. I can simplify expressions using the distributive property. Distributive property, something we did talk about in Chapter 1, but it is something we will review again now and put to use. Definitely something you're going to use in 8th grade and going forward in math, and something you do need to work on to be able to understand to make things a lot easier for you. So let's go on with doing that. So to simplify an expression is to perform operations to create an expression with less terms. In tomorrow's video, we will talk a little bit more about what the word terms mean. Terms is really just like the number of things you see when looking at an expression. So looking down here at just simplify, simplifying 2 plus 3 plus 4, you guys know how to add those together. You really just end up with 5 plus 4, which is the same as 9. So instead of having 3 numbers, we have this 9, which is actually the same thing. Then here, 3 times 4 minus 1 minus 9, we use our order of operations to solve. So we'd end up doing, I should be doing this vertically, but the way it's set up. So I'd end up with 3 times 3 minus 9. Then I do multiplication next. So what I did first was my parentheses. Then now I'm going to do my multiplication. So I end up next with 9 minus 9, and I end up with, this is the same as 0. So 0 is much simpler than all of this, and they're actually equivalent. Going forward then, let's talk about the distributive property. The distributive property, think about distributing. If I'm going to distribute some papers, I'm going to hand out things to everyone one by one. I'm going to distribute the papers that way. So what I can do, I'm going to show you the distributive property by showing that it makes things a little bit easier. So if we look on the left and we do parentheses first, and then we do multiplication, we'd end up with 3 times 9, and we'd end up at 27. If we go to the right and we look at distributive property, then we distribute first 3 to 2 and 3 to 7. So we have 3 times 2 plus 3 times 7. So then we end up with 6 plus 21, and we still end up back at 27. But notice then we come to this situation. Can we do, if we try to do parentheses first, then multiplication, the question is, are we able to? Are we able to subtract 3 from x? No, we're not. I can't take 3 away from x because I don't know the value of x. X and their variable are unknown. So I'm not able to do that. But instead, I can simplify this on the right by using distribution. I can say 2 times x, and I can say 2 times, this is a negative 3, or plus 2 times negative 3, and that's 2x, then plus a negative 6, which is the same as 2x minus 6. Here's another trickier one, and we'll go over examples from the book with these, but just a little preview. Notice on the left here, I've marked look out. We have to look out for this negative in front here. This negative can trick people. So what we have to do is still distribute. We can't do anything on this side. We can't do x minus 3. So we do have to use our distribution. So we distribute negative 2 times x, and then plus that negative 2 times, that's supposed to be a 2, times that negative 3. Okay, so what we get then is negative 2x plus a positive 6. Negative times a negative is a positive. So what we notice then is that the expressions, and this is maybe a little bit different, there should have been a plus on this side. Say we did this with a plus 3, 2x plus 3 and 2x plus 6 are equivalent expressions because no matter what x is, the expressions have the same value. Okay, so then looking on page 416, examples to use writing expressions with addition involved. So use the distributive property to rewrite each expression. So we have 4 times x plus 7. Really, we distribute that 4 to both x and to 7, as shown here. Then we simplify by doing 4 times x is 4x. 4 times 7 is 28, and that is our simplified expression. Example 2, even though 5 is on the outside, we can still distribute it. So we do 5 times y, 5 times 2, and we simplify using the commutative property. We do 5y instead of y5. You always have to get used to writing your number, then your variable, not your variable, then your number. Don't do that. Okay, so there's some for us to try here. So I'm going to try 6 times a plus 4. So I distribute my 6 to a, which is 6 times a. And I distribute my 6 to 4 plus, which is 6 times 4. And then I simplify 6a plus 24. Distribute my 8. 8 to n is 8 times n, or n8. I always put my number first. And 8 times 3, which ends up being 8n plus 24. Lastly, then, we have a negative 2, okay? You have to take the negative in front. So this is negative 2 times x, which is negative 2 times x, plus negative 2 times 1. So negative 2 times negative x is a negative 2x times x. And then negative 2 times positive 1 is a negative 2. We can actually just write this. Adding a negative is the same as subtracting 2. So negative 2x minus 2. I would rather minus 2 than have plus a negative written down. Some examples with subtraction then are using the distributive property to rewrite each expression. So look back at how to review multiplying integers. Positive times a positive, negative times a negative, etc. So again, we do 6 times p and 6 times negative 5. Notice what we did was we rewrote p minus 5 in the inside as p plus a negative so that we could tell that we are multiplying 6 times a negative 5. Because sometimes when you're using just this way, sometimes we tend to forget that this is 6 times a negative 5, taking the sign in front. So instead, some people just do the chop minus to do that. So we have 6 times p plus 6 times negative 5, which is 6p plus a negative 30, which is the same definition of subtraction as doing minus 30. Example 4, same type of thing. We're distributing negative 2 to both x and to that negative 8. So we change it to a chop minus, shown here, and then we distribute 2 to x, negative 2 to x, and negative 2 to negative 8. Negative 2x is negative 2x. Negative 2 times negative 8 is a positive 16. Integer rules. So give these a try. You might want to pause and then come back after you've tried them. So then I do 3 times y, 3y. 3 times that negative 10 is a negative 30. Maybe I'll do this next one a little bit more like the book example. -7. First, I'm going to rewrite it. That's -7 times W plus -4. If I do that, chop minus to be able to tell. So then I distribute 7 to W, -7 times W plus that -7 times -4. So then I get -7W plus a negative times a negative is a positive 28. Over here then, same thing. I may want to change this, chop minus first. So then I have n plus a -2 times a -9. And then I distribute. So I'm going to distribute -9 to n. Just -9 n plus -9 to -2. So I end up with -9n plus positive 18. Pretty cool. Just a couple, 3 more to practice, and then you can be on your way to do your NICU. These ones are a little different because they have a coefficient. This kind of leads us into tomorrow. These ones are a little bit more challenging if you want to try on your own. So you can do -2 times 3y and -2 times -8. So I rewrite that. -2 times 3y, and then that's a plus -2 times a -8, which is the same then as doing, that's a -6y plus the negative times the negative is 16. Second one, same deal. 5 times x is 5x. Maybe add the opposite if you need to. That's a 5 times a -11 or a -55. Lastly, then you have a -2 times 5y should be a -10y. The y stays alone. Then -2 times a -8, which is a positive 16. So I just changed it to an addition sign instead of subtracting a negative. So that is, in a nutshell, day 1 of 8-1. So watch the video, watch someone else's, read the book, personal tutors, Khan Academy, anything you need.